Hey everyone, and welcome. Every single time you browse the web, you're using this invisible language that makes the whole thing work. Today, we're going to decode that language, and we're going to look at HTTP and its much more famous, way more secure sibling, HTTPS.
You've seen it a million times, right? That little padlock up there in the address bar? We all have this vague idea that it means secure, but what is it actually doing? Well, turns out that tiny icon represents a huge story, an evolution in how the internet learned to keep our secrets safe. And to get it, we have to start at the beginning.
So to really understand that padlock, we gotta go back in time. Let's meet the OG, the protocol that literally built the World Wide Web as we know it, HTTP.
So HTTP stands for HyperText Transfer Protocol. And really, all it is the basic set of rules that lets your web browser have a conversation with a web server. It's the fundamental grammar of the web, dictating how we ask for things like websites or images and how the server sends them back to us.
In that conversation, it's actually super simple. First, your browser makes a connection to the server. Second, it sends an HTTP request, which is basically it's saying, hey, can you send me the stuff for this website? Third, the server says, sure, let me find that for you. And fourth, it sends back an HTTP response with all the code, pictures, and everything else you need. It's just a simple back and forth.
But, and this is a huge but, this simple conversation has a massive fundamental flaw. Imagine you're sending a secret message. You wouldn't write it on a postcard for anyone to read, right? You'd put it in a sealed envelope. Well, HTTP basically sends everything on a postcard. And that's the core issue. HTTP sends every single piece of data, your username, your password, your credit card details, in plain, unencrypted text. Anyone who happens to be on the network between you and the server can just intercept it and read it like it's the morning paper.
So what does this whole postcard problem actually mean for you in the real world? What are the actual consequences? First, and this is the big one, there's zero encryption. Your private information is just out there, totally exposed to anyone who might be eavesdropping on the connection. This is exactly why you should never, ever enter sensitive information on a website that only uses HTTP. Second, there's no authentication. With plain old HTTP, your browser has no way to prove that the server it's talking to is the real deal. You might think you're on your bank's website, but you could actually be talking to an imposter server set up to steal your login info. That's a classic man-in-the-middle attack. And third, no integrity. This means that the data you're getting back from the server could have been messed with along the way. A hacker could literally inject malicious code into the website before it even reaches your computer, and you'd be none the wiser. So, with all these massive security holes, the internet was kind of like the Wild West. It needed a hero, and that hero came in the form of a single, powerful letter, S, for secure. Now, here's something that trips people up. HTTPS isn't some totally new protocol. It's just a regular HTTP, but it's been wrapped in a powerful layer of security armor. That armor is called SSL/TLS. So you can think of it as HTTP wearing a bulletproof encrypted supersuit. And what does that supersuit do? Well, it directly solves the three huge problems we just talked about. It provides encryption, which seals our digital postcard. It provides integrity, which means the message can't be tampered with. And it provides authentication, so we know for sure who we're talking to. So how does this secure connection get started? It all happens in a flash with something called the TLS handshake. Think of it like a secret handshake. Your browser says hello to the server says hello back and shows its ID card. That's the SSL certificate. Your browser checks to make sure the ID is legit and from a trusted company. Once they both know they can trust each other, they secretly create a one-time use key to scramble their entire conversation. Only then does the actual HTTP traffic start flowing, completely encrypted.
When you put them side by side, the difference is just night and day. HTTP is unencrypted, uses port 80, and gets you that scary, not secure warning. HTTPS, on the other hand, is fully encrypted, uses port 443, authenticates the server, guarantees your data, and earns that beautiful little padlock icon. It's not even a contest.
Okay, so problem solved, right? The web is secure, we can all relax. Well, not quite. As websites got more complicated, with tons of images and videos, a new enemy appeared: lag. The old way of doing things was just too slow. And this quest for speed has driven the protocol's evolution ever since. Way back in '97, HTTP/1.1 made things a little better. But the real game changer was HTTP/2 in 2015.
And now we're in the era of HTTP/3, which is a total redesign built for the modern mobile internet.
To understand the jump from version 1 to 2, just picture a traffic jam. HTTP/1.1 was like a single-lane road. If one big slow truck, like a high-res image, was in front, everybody else had to wait. It was called head-of-line blocking. HTTP/2 completely changed the game with multiplexing. It turned that single lane into a massive, multi-lane superhighway. Now all the cars, the images, the text, the scripts can all travel at the same time in their own lanes. It's why modern websites feel so snappy.
But you know how it goes with tech, right? Faster is never fast enough. The engineers behind the web wanted to push the limits even further, which brings us to the most radical change yet, HTTP/3.
All right, so HTTP/3 changes the very foundation the web was built on. For decades, everything ran on a system called TCP, which is like a super careful delivery service that checks and double-checks every package. It's reliable, but slow. HTTP/3 rips that out and uses a new protocol called QUIC, which is more like a fleet of smart independent drones. It's way faster. It allows for almost instant connections to sites you visited before. And get this, it lets your connections seamlessly migrate. You know when you walk out of your house and your video call stutters as it switches from Wi-Fi to cellular? HTTP/3 is designed to make that transition totally seamless. It's built for the world we live in now.
So the journey has been pretty incredible, right? We've gone from an insecure postcard to a system that's fast, resilient, and secure by default. And that brings us to the key takeaway. HTTPS is not a feature or a nice-to-have anymore. It's the absolute, undisputed default for everything we do online. Security is no longer optional, it's the very foundation.
So we did it. We made our digital conversations private, and we made them lightning fast. The postcard has been replaced by an armored, supersonic jet. And that leaves us with one last big question to think about. Now that the web is both secure and fast, what's the next great challenge we need to solve? What's the next frontier?